Hello everyone, my name is Waleed. I'm an engineer at Introspect, and today we're at our research lab, and we're going to be doing a demo of the RSH2. So RSH2 stands for Remote Sampling Head, and this is a device that we use for active probing. This is a very neat device that has 12 active probes packed into one very clean, easy to use device. And today what we're going to be doing is demonstrating how to use it to actively probe a phone. So this is used to probe high-speed buses, and in this case, what we're going to be doing is probing the information and the data that's coming out of the camera on this phone, and we're going to do a data capture and try to figure out what is the data that's being transferred from the phone's camera. So for the physical setup, we actually have the phone here connected to the RSH2, which is then connected to the analyzer, which is the SV5. So what we're actually doing here is probing a high-speed link between the camera and the application's processor. And this high-speed link consists of a MIPI D5 physical layer carrying CSI2 protocol traffic over the bus. So we have the data being transferred over 4 data lanes and 1 clock lane, as is the case for D5. It's going into the RSH2, and the data is going to the RSH2 where it is amplified, and then it's passed on to our SV5 analyzer. And the SV5 is a very powerful tool which is used for interpreting and analyzing and capturing high-speed data. And so this will allow us to interpret and understand what is going on in this phone. And now I will go ahead and actually demonstrate how to do the capture using our Pine Tree software. Okay, so now I'm going to go ahead and demonstrate how we can use the Pine Tree software to actually do the capture. So in this case, we have a simple test procedure opened up. We're going to connect to the SV5 analyzer. So we're now connected. In this case, we have a simple procedure. We just have the clock config and the CSI data capture. As I mentioned earlier, we're going to be capturing a CSI image. So this is the appropriate component to use. The settings are quite straightforward. We're just using default settings. We're going to trigger on the frame start. And for post-trigger condition, we have it set to 1. So we're just going to use just capture 1 frame. So that's all that we want to do. And I'm going to go ahead and click Run so that the capture can start. We can see here that it triggered. The capture is starting. The burst information is being extracted. And the data packets are being processed and results are being written. So this is going to take a little bit of time. We expect this to be a big image. So we're just going to wait for it to complete. Okay, so the data capture is now complete. That took about 1.6 minutes. We can go ahead and analyze the results, which are summarized in the results panel. So we'll open up the CSI data capture results panel here. So all the information that was that we captured on the live, as we probed the live traffic coming out of the phone, is summarized here. We have the burst information, the CSI packets, LP states, LP events. But I think what's most interesting is actually to visually look at the image that we captured. And so that would be in the frames panel here. And here we can see the image that the phone was transferring. So this is, the phone was pointing up towards the ceiling. We can see some of the ventilation captured here. So this is what we expected to see, and this is very interesting and exciting that we're able to catch this. But this is also revealing over here something very interesting about how this phone works, because we actually see here 2 images. So we remember we were going to capture, we were expecting to capture just 1. But here on virtual channel 1, we've captured a second image, which is a smaller image, and appears to be a subset of the first one. So this is very interesting, and it tells us how this phone is working. They're phones that, it's not, we don't know for sure, but they're phones that employ computational tricks such as PDAF, which is phase detection out of focus, to produce professional looking images. And this looks like this extra information is being sent along with the main image for autofocusing techniques. So this is one of the one of the processing techniques that are used in some of the phones, and we believe that this is why this image was being transferred as well. And so this is very interesting to learn on how this phone is functioning. We also have other information summarized here about this image that we captured. So we can see the data type, which is a raw 10. We can see the resolution here summarized for the main image. This looks like a 16 MB image, and the timing information is present. And there's also, for example, if one wants to dig further and try to analyze the packets that were sent, there's packet by packet information available in the CSI packets panel. And here we have, for example, we can see that the first packet is a frame start data type. And remember that we were triggering on the frame start, so it would make sense that the first packet would be the frame start. So that's summarized here. And then we have the byte information summarized at the bottom. Again, if there were errors, we wanted to analyze what was going on the live bus, then we can actually analyze this further. And then all the packets are further linked to the bursts. So if you want to, again, analyze burst information, look at bit by bit information, all that is summarized here at the bottom in these different panels. So that concludes what we wanted to share here in the results panel. And this is a very nice overview of the analysis techniques that are available through the SV5. Okay, so this concludes the demonstration for today. We were able to actively probe the live traffic on a phone using the RSH2. We were able to see the images that we captured using the Pinetree software. A big surprise for us was that we saw two images, and one was being transferred on a different virtual channel than the first one. And we believe that this is being used for autofocusing techniques. And then we also showed the efficiency and the capabilities of the SV5 analyzer, which is being used in a DeFi configuration to capture a CSI image. So this concludes the session for today. Thank you for listening.